In this video, we're going to talk about the relationship between pressure and the amount of gas. In chemistry, we refer to the amount of gas in moles. Moles is just a unit, just like dozen or pair. Dozen meaning 12, pair meaning 2. Mole means a lot. It means this number. So that's a huge number. So we're just going to call it mole, and just know that we're talking about gas, or the amount of gas. Here we have two boxes. Now they have equal volumes, and we're going to say that they're at equal temperatures. Let's just say that they're both at 25 degrees Celsius. This is about room temperature. Okay, so the volume is constant and the temperature is constant. However, in box 1, in this box right here, N, which stands for moles or amount, we're going to say we have 3 moles. Each of these is representing 1 mole of gas. And in box 2, we have 6 moles of gas. So the question is, how is pressure affected? Well, pressure is the collisions and the amount of collisions and the force of collisions that gas has with the walls. So if they have the same temperature, they are moving, all of our gas molecules or particles are moving at the exact same speed. Okay, so I am representing that by having these arrows being the same length, or trying to make the arrows the same length. So they're moving at the exact same speed. However, I want you to notice that we only have 3 moles here, whereas we have 6 moles here. So which box has more frequent collisions? Obviously box number 2, right? This one is colliding, this one is colliding, this one. We have 4 colliding in this instant, whereas over here we only have 2 colliding. And again, these are constantly moving around, so different amounts will collide. But because we have more moles in box 2, we will always have more collisions. And when we always have more collisions, we're going to have a higher pressure when we have more moles, when we have more collisions, so a higher pressure in box 2 and a lower pressure with fewer moles in box 1. So just to recap, more moles equals more pressure. Those are a direct relationship. The more moles you have, the higher the pressure, if you have constant volume and temperature. So the example says 10 moles of a gas is at 3.5 atm. How many moles are there when the pressure changes to 1.5 atm and the volume and temperature remain constant? So remain constant means doesn't change, so we don't really care about the volume and temperature. They are not changing. We have 10 moles, so that's our amount. So I'm going to call that N1. Amount 1 is 10 moles. And its pressure, P1, is 3.5 atm. Then we have the pressure changes to now, so we know P2 is equal to 1.5 atm, and it says how many moles. That's what we're looking for, and 2 is our question mark. So we have all this information. We know that from P1 to P2, pressure is decreasing, right? It's going from 3.5 to 1.5. So therefore, we know that from N1 to N2, our amount of gas needs to also be decreasing, because if pressure is decreasing, then the moles decrease. If we have less pressure, we have a lower amount of gas. So I'm going to start with our 10 moles. And now I'm going to figure out a way to put my pressures in a fraction that will allow me to calculate a lower number of moles. So in this case, 1.5 over 3.5, well, 1.5 is less than 3.5, so this is going to be less than 1, whereas 3.5 divided by 1.5 3.5 is bigger than 1.5, so that'll be greater than 1. So if I want to decrease my number of moles, I need to multiply it by something less than 1. So I'm going to multiply it by 1.5 ATM over 3.5 ATM. When I multiply this out, I get 4.3. I need two significant figures. Even though there's 3 significant figures right here with my number of moles, my pressures both only have 2 significant figures. So I'm going to choose my lowest amount of significant figures, and I get 4.3 moles. Another way to think about these problems is to use this equation, P1 over N1. My pressure and amount divided by my amount of box 1 is equal to after it changes, the pressure and the divided by the amount after a change. So in this case, I'm doing the same thing. I'm just plugging in my numbers, 1.5 ATM over 10, I have my P1 is 3.5 ATM. So 3.5 ATM over 10.0 moles is equal to the 1.5 ATM, which is my P2, over my moles, and that's what I'm calculating. And using cross multiplication and solving for N2, you would get the same exact answer and the same setup as right over here. So I find this method to be easier to think about how am I going to make this number smaller, which fraction am I going to use. But if you find the equation method easier, please feel free to use that one. Go ahead and complete the rest of this worksheet.